All right, hello everybody. Welcome back to Unit 2, Lesson 2. Ignore the top. That is my mistake. That should be Unit 2, Lesson 2. It should also be the derivative again. So just, let's fix that. It should be Unit 2, Lesson 2. All right. So if you did the homework, here are the answers. I did them out. It's pretty rough, but these are the two answers that you should have gotten. All right. Without further ado, let's get into today's lesson. So this is going to be Lesson 6. Excuse me for a moment. I mean, not Lesson 6, my apology. This will be Unit 2. Lesson 2. We're going to talk about how to estimate a derivative. And then we're going to talk about the power rule. Actually, no. We'll talk about the discontinuities of derivatives. So we'll talk about estimating a derivative. So I'll just write this down. Estimate derivative. All right. Apologies. Let me just estimate derivative. All right, so we're going to talk about first how to estimate a derivative given a table. Basically, no matter what you get, a table, a function, if it's asking you to estimate a derivative, it's asking you to take the closest possible average rate of change. Basically, you get this x f of x. You get 1, 2, 3, 4, 5. And it wants you to get it wants you to have f prime of 4. It wants you to estimate f prime of 4. Let's say estimate f prime of 4, right? Let's say this is 10, 15, 20, 25, and 30. So f prime of 4 is going to be, so how are we going to find f prime of 4? Well, okay, probably should not include f of 4 there. Let's say that is going to be f of 3.5. Now, what should you do? Well, it's pretty obvious. We need to take the closest possible average rate of change. And since the closest thing that we have to the average rate of change is going to be, well, okay, let me draw a better representation of this. Let me make it a bit easier to understand. We're going to get it's like 5 and 7, and then this will be 25, 30, right? And then what we're going to do is we need to find the closest possible thing to f prime of 4, right? So how are we going to do that? I want you to think about that for a moment. How would we find the closest possible average rate of change? All right, it's going to be pretty obvious, right? You need to do f of 5 minus f of 3 over 5 minus 3. Why are we doing this? Because this is the closest possible thing to the slope of f prime of 4. Say this is the graph. Let's say it's a quadratic in this case. Let's say this is 320. Let's say this is 525. And then let's say this is 4 f of 4. f4. Right, if we want to get the tangent line of this, what we're going to have to do, this is going to be the closest approximation we're going to get. Because those are the two numbers that are closest together to it. So no matter what, if you see like a number like 4, then you should immediately check for two numbers that are the same distance from 4. You need to check for two numbers that are same distance from 4 and that are close to each other. Two nums that are the same distance from 4 and are close to 4. So like 3.5, 4.5 would be better. Or, like you can choose anything you want, right? But all you have to do is you have to choose something that is closest to the value that you want, right? So let me give you another example and let you do it by yourself. Let's say got x, f of x, all right. We'll say this is going to be 5. We'll say this is 10, 6, 7, 8, 9. And we'll say this is going to be 15, 20, 25, 40. And then I want you to estimate f prime of 8.5. I want you to do that for me, all right? So I'll give you a minute to do it. Take a minute. And just do this. So I'll give you the answer in 5 seconds. 5, 4, 3, 2, 1. All right, so the answer is going to be f of 9 minus f of 8 over 40 minus 25, or, my bad, that should be over just 1 for 9 minus 8, which is going to be 40 minus 25 over 1, which is going to be 15. All right. So, that is that. But, like, what if there's a specific scenario where we're given 1? So, like, for example, f of x, and then you might be asking yourself, okay, but, like, 2, 3, 4. 1, 2, 3, 4, 5. And then it asks us for, and then it's like 9, 10, 11, 12, 13. And then you may ask us, all right, let's say that this is a little different. Let's say this is going to be, this will be like 11, this will be 13, this will be 14, and this will be 15. All right? So, let me just erase that. I'm just write 14, that's going to be 15, that'll be 13, right? Let me just 5, 11, 13. All right, cool. And then it asks us estimate f prime of 4. You may ask me, all right, what are we supposed to do here? Like, how are we supposed to approximate the number closest to 4 here? Actually, you know what? Let's do even funkier thing. Let's do this. Let's change that to. Let's change this. We'll do 0, 1, 2. And you may ask me, all right, what are we supposed to use to estimate this, right? Well, we can't use 2 and 5, right? Because they're not the same distance away from 4. So we have to take the average rate of change of these two numbers, and we have to see, all right, what's the midpoint of those two numbers, and which one of these is closer to the number that we want, right? So what we're going to use is we're going to have to use the number that is like when you average it out, it is going to be closer to 4. So since excuse me. Since 2 and 4 are 2 away from each other, and 4 and 5 are 1 away from each other, it's obvious that we're going to have to use 4 and 5 to approximate f prime of 4. This would be better to approximate f prime of 4.5, obviously, but we work with what we've got, and this is the best that we have. This will be the best and closest approximation, because this will be the best approximation of 4.5, which will be the best approximation of 4. Because if we did this, if we did 2 and 4, that would be the best approximation of f3, which is not closer than f of 4.5, obviously. And then, yeah, basically, we choose the 2 numbers that are closer to each other in this scenario. We choose the 2 numbers that are closer to each other. All right, so I'll do f of 5 minus f4, 15 over 5 minus 4, which is just 1. Meaning this will just be equal to 1. Again, it would be better if we had a better approximation, but we work with what we've got. Okay, so that's it for estimating derivatives. And now I'm going to go into the discontinuities of derivatives. Where does the derivative not exist? This is the question we need to answer. There's going to be 3 specific scenarios that I'm going to talk about. There's going to be cusp, corner, and vertical tangent. This will be our vertical tangent. This will be our cusp. This will be our corner. Our vertical tangent looks something like this. Let's draw this, draw this, draw this. That's our vertical tangent right there. Now you might ask yourself, Jay, why can the derivative not exist here? Because look at this point right here. Look at that. Look at that. Where is that going? That is a completely straight line, right? And what do we know about completely straight vertical lines? Well, that's like the derivative will never. Okay, well, you don't know about that yet. Basically, the derivative will never exist if this is a vertical tangent, because that'll just go to infinity. That derivative will just go up and up and up and up forever without bound. Because think about it. This is just not possible, right? Because we're trying to measure the change. But how are we going to draw the vertical tangent of something like, for example, like we're going to have to keep drawing this and this and this and this forever and ever. Basically, what you need to get out of this is that it is not possible for a vertical tangent or something like that to ever be, like this point will never be derivable. A cusp. That is a cusp. That is also a cusp. The derivative from the right is not equal to the derivative from the left, and they're both going to infinity as well. That's basically what you need to know. Like this one is going to negative infinity, and then this side is going to positive infinity. Excuse me for a moment. Right? Meaning that it can never exist. Corners are very similar, except they're not going to infinity. It's just simply that the derivative from the left is not the same as the derivative from the right, meaning the limit as x approaches a certain number c of f prime of x is not equal from the left. It's not equal to the limit as x approaches that same number from the left of f of x. Right, and then this is just it's a pretty similar thing, but you have to see that it's like infinitely going down and then infinitely going back up. All right, so I'll give you 3 different graphs, and I'll let you see which one is a cusp and which one is a corner. So I'll give you these 2 graphs, and you gotta tell me this is a cusp or a corner. There's your first one, and then, or vertical tangent, I forgot. Yeah, cusps, corners, vertical tangents, all game. And then this is going to be your corner. All right. Oh, well, I just told you. Crap. Yeah, so this is a corner. You can pause for 5 seconds to figure out what this one is. 5, 4, 3, 2, 1. This is a vertical tangent. Because of, again, that straight line. We don't like those straight lines. That's why I was bolding it, to emphasize it. Alright, I mean, that's pretty much it. Next lesson is power rule. Basically, by the next lesson, you'll be able to take a function like this and instantly figure out that it is this. By the very end, you'll be able to instantly change it without even having to use the limit derivatives that we know. Those limit derivatives are still very important. You'll still be tested on them, but we won't be using them much anymore because they are very inefficient. So next lesson is power rule. Yeah, I mean, I guess that's all. Have a good day, everybody.